Well, hello, parents and guardians. Welcome to another weekly update on STEM with Mr. Gleason. Hope everybody is doing well today. Today's lessons, we focused on the E part of STEM for engineering. Now, let's recall that the goal of STEM in any model is to integrate the four subject areas and teach them in unison instead of treating them as individual, unrelated topics or sometimes silo. A STEM lesson then can include all four of these subjects or any combination thereof. However, for this week, we are focusing just on the E. And that is because the goal of engineering is to include skills that have the ability to create, systematically solve, collaboratively work in teams, effectively communicate, and address real-world issues while in the classroom. So what I noticed though this week from our young scientists is that we need to still branch out their scientific literacy. That is because according to them still, they view this as STEM. You have the individual components, math, engineering, science, and technology, but not much integration yet. So this would be the student view. Moving forward, this is how they see it, as I mentioned, seeing it as silos. However, the goal of STEM is to treat it as one unison. Everything overlaps, relates, collaborates, come back to each other. So we're going to try to go from separate disciplines to integrated disciplines, and there's no greater way to do that than by engineering. Therefore, within engineering for this week's discussions and lessons for this podcast, we focused on defining the problem, plan, make a model, test the model, reflect and design, all part of the engineering design process. However, which all of us need to help out at home, on the school bus, anywhere we can, is we need to plan and make a model. We need to slow down the process. That is because it's not individual units. Everything relates back to each other. So if we don't master one area, it's hard to go on because our ultimate goal is to get the STEM integration. Therefore, our challenges for the week were you and a team are confronted with the challenge of constructing a mechanism to keep a golf ball from touching the floor while dropping it from 6 feet. You have 20 minutes to design. The goals of this STEM engineering project was to work productively in collaborative teams, make decisions based on objective measures and data, fail, and then recover from it, and that comes back to the build a prototype and follow the design process. Will you actually go through all of the steps? That was project one. The second one is similar in the goals. However, you're going to make a CO2 dragster that can go 60 feet in under 5 seconds. Goals, collaboration, communication, establish a real-world connection, and optimize the design solutions. So that is getting back to here. However, students want to go from here all the way to the bottom instantly, and this is where you are vital at home, is to slow this process down. So key skills that I noticed we need to fine-tune is planning and collaboration. There was not much planning involved in any of the STEM activities. So we can reassure to the students that it's a marathon and not a sprint. Seek out help and ask those questions. Do not just fill in the gaps on your own. That's why we're a collaborative team to help out. So these were some of the thumbnail sketches for our CO2 cars. You can see the block of wood here. Some of it symbolizes not much variation. Students just wanted to get done. It even says draw at least 8. And you have the mystery machine here, which is nothing you could get out of the piece of wood. So this is an example of the CO2 dragster of we need to slow down and plan more. The other one was the golf ball drop. You can see we do have planning. One student is actively engaged. The other is just watching them do it. And you can see here's what they made. However, it looks great, their design, but after talking with them during the design process making, they just were making improvements as they went because that was their original, does not look much like what they were actually producing. Therefore, here's what you can do. Walk through with your child, granddaughter, grandson, anything you want. Let's walk through actual worksheets that they see in class. So here we go. This is what we're going to do before. What is the problem? What are the solutions? What materials? And let's sketch out a real plan. Therefore, after we try the prototype, let's go back through and talk about what worked well, improvements made, and what did you learn. Talk about the roles within a team. This is stressed in STEM. You're a collaborative team. You're a collaborative team. Therefore, sometimes you have to lead, sometimes you have to follow. Therefore, have active conversations at home about what are the roles, what does a director do, what's a facilitator, technician, materials manager, even participation. What does that look like to be an active member? So next steps moving forward. Okay, you can do a STEM activity reflection, or you can even include the art aspect and do the STEAM activity reflection. Provide increased opportunities for discussion. Okay, this is key. Talk about science, technology, engineering, art, and math, how it relates together as a whole in real world, because reflection in STEM is essential to both the student understanding and teacher evaluation of the student's learning. Reflecting helps students make connections, understand their success and failures, and become aware of their learning. Reflection helps teachers identify where students are in the learning process. So, what that looks like, once again, these are real-world worksheets that you will be getting this week in your child's folder, so have a look. Provide increased opportunities at home or on your projects for discussion. Look at here. This goes into Bloom's taxonomy, which basically means how do we move through our levels of thinking? What does it mean? What happened? So just simply ask these questions. What is the best one? Why did you pick that design versus the other one? Once again, another real-world example. Provide increased opportunities for collaboration. So you're going to create this. Can you create new and unusual uses for this in a team? How would you test this in a team? Provide increased opportunities for discussion. Once again, come back to questions. Get that thinking. Don't leave a solution. You want to design solutions. So how can you improve this? How can blank be applied? By having them think about more questions, their planning and collaboration will grow. So what to expect in upcoming. Next week's units, we will be focusing on a solar cooker, as well as an Army Man challenge. As you can see, have those conversations about plan A versus plan B. What materials do you need? Let's sketch it out, build it. Did you test it? How did you test it? So let's make sure we're moving forward in the right direction of slowing down. Therefore, the reason we are doing this is to focus on constructive response in the classroom. And that is because constructive responses can be more than just a simple multiple choice. It goes well beyond concept maps, flow charts, show your work designs, label. All of this helps to yield a range of responses from a student. And that is key because classroom assessment should, 1, promote learning, 2, use multiple sources of information, and 3, provide fair, valid, and reliable information, and constructed responses within our STEM unit focusing on engineering is key for that. So, by having those conversations, you go from this of one student not working to the end result of all students actively engaged. And you go from a drawing that you're really not focusing on the actual problem or defining the problem to a car that did go 60 feet in under 5 seconds. Thank you, and tune in next week for another great podcast on STEM with Mr. Gleason.